Okay, so in this video, I want to go over a different looking type of trig problem where you're required to use one of the three common trig functions, sine, cosine, or tangent. So with the picture that we're looking at, if I want to find, I just realized that I put my x in the wrong spot. So let me erase that, because actually what I want to do is solve for the measure of angle K. Let me do this. Let's say measure of angle K equals. So I'm trying to solve for the measure of an angle here. Okay, so what I want to do first, and I just drew this the picture that you're looking at, so it's not really 100% the best drawing, but I labeled the numbers. We have our 45 degrees for the measure of angle H, and then the length of the hypotenuse HJ is going to be 3 times the square root of 2. Okay, so what I would start out by doing is referencing the pattern that we see with a 45, 45, 90 triangle. So 45, 45, 90 triangle is an isosceles right triangle. That means that my two legs on the right triangle are going to be congruent. So let's say, for example, that I have a length of x, okay, for the legs here. Well, then my hypotenuse is going to be x multiplied by the square root of 2. So that's going to be useful information when I'm solving this problem. And in reality, since I know the trig function, sine, cosine, tangent, and I know the ratio of what they represent, I wrote SOHCAHTOA down here in the bottom right because we know that sine is the relationship of the opposite side over the hypotenuse. Cosine is a ratio of my adjacent side over the hypotenuse. Tangent is a ratio of my opposite side over the adjacent side. So I wrote SOHCAHTOA down there in the right-hand corner. I could use trig to solve for like this side right here. I could use trig to do that. But like I was explaining, if I know that there's a pattern with a 45, 45, 90 triangle, I could use that to my advantage so I could solve this problem with maybe less calculation on my calculator, okay? So if my hypotenuse, right here, HJ, is 3 times the square root of 2, then that would mean that my leg would have to have a value of 3. So this side has a value of 3. This side also has a value of 3. The side that I just wrote, I'm going to erase that. Why? Because that value of 3 isn't really necessary or beneficial for answering my overall question, which is finding the measure of angle K. So now that I have a side of 3, and I also have the other side of the right triangle, 5, what I would do is, let me highlight the triangle now that I'm looking at, just so you have a reference of understanding. Now we're focusing on this triangle since I want to find the measure of angle K. All right, so in reference to angle K, this 3 is going to be the opposite side, and then the 5 is my adjacent side. So then with that information, I would look at my 3 trig functions here and I would ask myself, which of these gives me a ratio of opposite and adjacent? And that would be the tangent trig function. So I would say tangent of angle K is going to be the ratio of 3 over 5. Now, if I want to actually find the value of this angle, the degrees, the measure of the angle, what I would do in my calculator is I'm going to use the inverse trig function. It has this -1 you can look on your calculator, plug that in. So -1, 3/5. And if we plug that into our calculator, we're going to get a rounded value. So I'm going to say that the measure of angle K is about, you should get 39, or I'm sorry, 30, like 0.96, about that much. And of course that's rounded, and that's degrees, since we're finding the measure of an angle. If you do not get that value, you might want to check the settings on your calculator and make sure that your calculator is in degree mode and not in radians. So I hope that this video was helpful so that you can solve for the value of a missing part of a right triangle using trigonometry.